All right, y'all, welcome to Algebraic Reasoning. Today we're going to discuss literal equations. So we're going to be talking about literal equations. What are literal equations? Literal equations, I like to think of them as almost the physics problems. These are the questions that ask you to isolate a particular value. In other words, we're going to rearrange equations. And the most important thing to think about when dealing with literal equations is you're doing the same exact thing that you would be doing if you were just solving for x or solving for y. Okay, so what do I mean by that? Well, let's look at the first one. 6x equals 7 minus 4y. If it's asking me to solve for y, so this means I'm just going to try to get y by itself. So we know when we see a linear term or a number and a letter next to each other, and then we see another number, we can move the other number to the other side by subtracting it. So we're going to say minus 7 minus 7. Now, can I put 6x minus 7 together? The answer to that is no. Why can't I put 6x minus 7 together? Because they're different terms, right? 6x has x in it with it. 7 is just 7. So you can't put them together, but you can move them to this. You can subtract 7 from both sides, in essence, and keep the right side a little bit more simple. You get one step closer to getting y by itself. Okay. One other thing here that I want to stress is that I did say move negative 7 to the other side. I'm not technically moving negative 7 to the other side. I'm subtracting 7 from both sides. And by subtracting 7 from both sides, I'm balancing the equations. So I want to use technical jargon here to make sure, but at the same time, if that's the way you're thinking about it, to kind of drive your intuition, that's fine. Okay, last bit. If I'm trying to get y by itself, then I can just divide by negative 4, right? Now, very important, when you divide by negative 4, anytime you multiply or divide, these are called, the fancy term for this is scalars. But basically what you're doing is if you amplify or you minimize every single value by a certain amount, the equation retains its ability. So what I'm trying to say is if I have something like 2 equals 1 plus 1, right? If I decide that I want to multiply everything by 3, I would get 6 equals 3 plus 3, and that would still be true, right? And then if I turned around and I said, okay, well, let me divide everything by 3, then that would be 2 equals 1 plus 1, and that would still be true, right? So as long as everything is being scaled by the same amount, it's okay. So I can divide through, but I have to divide every term through by negative 4. So also note that when I write this right here, this is the same thing as saying 6x over negative 4 minus 7 over negative 4 is equal to y. So these two mean the same thing. Now, I think it's a little bit more elegant, a little nicer on the eyes if I leave it as 6x minus 7 over negative 4. So that's how I'm going to leave it. Boom. There's my answer. Okay? All right. One last note here. You do have negative negative here. Negative negative becomes a positive. So if you were going to write it this way, you could, and you can also reduce this. So if you wanted to, you could leave it as negative 3 over 2x plus 7/4 equals y. And also, if you end up putting y in front, so here if I wrote y equals 6x minus 7 equals negative 4, that's acceptable. Or here y equals negative 3/2 x plus 7/4, that's okay as well. So you can leave it like that. I guess you could also, with this one here, if I just want to just be super clear, if I put the negative on top, this is okay. And then we can also go with distributing it out. And that's okay as well. So there's a lot of versions of these that we can rewrite if we want. I think that this is fine though. Okay, let's move on. All right, next one. One last thing here. I'll take it back. One more thing to do. And that's it's asking solve for when x is negative 2 or 0. Okay, so this is building you up to an idea that we see a lot in math. So again, I'm going to use this equation right here. So let me write it. I guess I'll use this version. So y equals 6x minus 7, negative 4. And then it says solve for x equal to 0 or 2. So what do I do there? Well, this is just saying plug in 0. So it's going to be the same equation. Only instead of x, I'm going to substitute in 0. So now when I solve this, 6 times 0 is 0, negative 7 over negative 4, or just negative 7 over negative 4, which is 7/4. So when x equals 0, y equals 7/4. Now if this was an equation of, let's say it was on the xy plane, we could even write it as a coordinate, 0, 7/4, which we'll go into more later. Okay. Then we do the same operation again. Let me rewrite it. I'm going to have to squeeze it in because I'm at the end of the page. Okay, minus 7 over negative 4. And then if I give you 2, I guess I'll do it in a different color here. 2, we just plug in 2. So what happens here? Well, this is going to give me 12 minus 7 over negative 4. 12 minus 7 is 5, so 5 over negative 4. So again, if x is 2, y is negative 5/4, or 2 comma negative 5/4. Okay? So this is the advantage of doing this. So a lot of times we like to isolate a particular variable so that we can, and then you can substitute values in to figure out what's the sort of value that we need to solve for. So if you plan on going beyond in math, this is something that you're going to see over and over and over again. Very important skill. But now let's move on. Okay, 5b plus 12c equals 9. We're going to solve for b. So we're going to isolate b, okay, which means you want to move everything else to the other side. So if we have plus 12c, we can subtract 12c from both sides. So we're going to get 5b equals 9 minus 12c. All right, next move, we're going to divide through by 5. And I'm just going to divide everything through by 5. So b is 9 minus 12c over 5. That's it. That's all you got to do. Okay, let's move on. Next one, we're going to solve for x. Okay, so this one is going to be high degree of difficulty because we have minus xy here, and then we have a 7x. So what we're going to have to do is we're going to have to decide, do I want x on the left or the right? Well, I'm going to go ahead and put it on the right side. I'm sorry, on the left side. So I'm going to add xy to both sides. And notice here that when we do this, we're going to get 7x plus xy minus 2z equals 4. And that I didn't put my x's together because they're not like terms. Okay. Now I only want x's. So what I'm going to do now is always, if you can move the value that has nothing to do with the previous one, you go ahead and do so. So when I move the 2z, we're going to have 4 plus 2z in the back. Remember, they don't go together because they're not like terms. And here we have 7x plus xy. Okay. Now, what's my next move? Well, they both have x in them, so this is the new move. We can factor in x out. Okay, and what do I mean when I say I can factor in x out? This is an extremely important move that's new. Okay, all I'm doing is reverse distribution. So notice that if I distribute, right, x times 7, that's 7x, x times y is xy. I am doing the same thing as distributing, but I'm doing it in reverse. So I'm actually dividing through by x. So notice what I did here. Divided through by x, put the x on the outside, and then that left me with 7, that left me with y. I wrote that inside the parentheses. Okay? So it's reverse distribution. That's what factoring essentially is. Remember this. If you struggle with this, then FOIL back, distribute back in the value of x into the parentheses and see if you get back to the original top term. So notice that if I distribute, I do get the orange, 7x plus xy. Okay, almost home. So notice now at the end, we are multiplying. The opposite of multiplication is division. So I'm going to divide by 7 plus y, because the goal is to get x by itself. And this leaves me with x equals 4 plus 2z over 7 plus y. Okay, let's move on to the next one. Okay, so they're going to put it as a word problem. The formula for the volume of a cylinder is V equals pi r squared h, where r is the radius of the cylinder, h is the height. Solve for the volume. I'm sorry. Solve for the formula. Solve the formula for h. What is the height of the swimming pool, cylindrical swimming pool, that has a radius of 12 and a volume of 1810? Okay, so blah blah blah. It's basically saying volume equals pi r squared h, and I'm asking you to get h by itself. So don't let this confuse you. If you look at this, you're multiplying, so the opposite of multiplication is division. If I'm trying to get h by itself, I just divide by pi r squared. So v equals pi r squared. I'm sorry, v over pi r squared is equal to h, and I'm done. Okay. Now the second part is saying, well, what if the radius is 12 and the volume is 1810? So we know that if that's the case, the radius is 12, I can plug that in for r. The volume is 1810, I can plug that in for v. And so I'm going to have 1810 divided by pi, and then r is going to be 12 squared. Okay, so notice what I did there. The v I'm putting in blue, right? And that's 1810, right? The r I'm putting in purple, right? And the r is 12 feet. And then you just solve for h, okay? Now, this is something that's a little messy, so we can go ahead and do this on a calculator. So we can see here, I typed it in the calculator, we can see that when we get this, we get our final result, which is roughly 4, okay? One little note here, if you hit alpha, this is really useful, alpha y equals, it doesn't work on every version of a TI calculator, but many versions, if you hit alpha y equals, it will allow you to write it as such, which is a fraction. So that means you don't have to worry about the denominator. So I know most of y'all have the Wabbit calculator. Test to see if that works, and I think it does. And if it does, then it'll make it easier to type in. It's a really nice technique. Okay. All right. So we got that. Let's move on. Okay. Last one. Well, actually, second to last one. All right, so this is asking us to solve for x. So the big thing here, this is actually very simple to solve. You just remember, I don't like fractions, so I'm going to multiply through by x to get rid of the fraction. It's a letter. Who cares? It's the same process. So I'm going to just rewrite what I originally had. So notice, as long as in your head you can realize that when you solve, the way we normally solve equations is the same way we solve literal equations. Literal equations are a cinch. Okay? So if we multiply through by x, notice I just rewrote the same equation, and I put an x in front of everything, then this will divide out, and I'll be left with a minus b equals x times c. Again, the goal is to get x by itself, so this is multiplication. Opposite multiplication is division. Just divide by c. And it's as easy as your ABCs. There you go. Bad joke intended. All right. One last situation that I want to talk about, and because this is super useful, is format ax plus by equals c. So you're going to see I have a lot of equations in the future that are going to be like this. So this is a really useful equation. Let's say I'm trying to isolate y. I want to know what y equals to. Okay? So to do this one, we're going to subtract ax from both sides. So we'll arrive at this. Okay, and then we would divide through by b. Now here I'm going to actually divide every term by b, and there's a reason why. Okay, it's fine if you didn't, but this is I'm actually trying to show you the utility of doing what we've just done. Okay, and one of the coolest usages of this is later on in the semester, and most of y'all probably recall, this is something that never goes away in high school mathematics, is y equals mx plus b. Okay. If you notice here, this value here corresponds to m, and this value here corresponds to lowercase b. So what I'm trying to tell you is if you have, notice this says ax plus by equals c, right? So if I have an equation like 2x plus 3y equals, let's say 5, let's say 18, okay, then I don't actually have to do any mathematics to figure out what the slope is, because I already know the slope is negative a over b, because that corresponds to m. See how this matches up? So all I have to do, this is a, this is b, it's just going to be 2 over 3, but remember it's negative, so it's negative 2 over 3. There's your slope. Okay. I can even do this if I ask b is called, so this is m is called the slope here. And you don't need to know what these terms are right now, but I'm just letting you know what they are to show the utility. This is the y-intercept. So I could even turn here and I could say, okay, so let's say I ask you what is the y-intercept? Well, it says c over b. So we know c is 18, we know b is 3, so 18 divided by 3 is 6. So just like that, minimal amount of work, you know that b is 6, b being the y-intercept, and you know the slope is negative 2/3. Super, 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 super useful. Okay, so this is just one example of how literal equations is very, very, very important. I want to say this, if you end up having to take physics, this becomes very important. All right, that's it, guys. Hopefully this makes sense. If you have any comments, questions, please reach out to me. Y'all know how to do that, and I'll see you in the next math video.